timer to 13 minutes. That's the time for the presentation, and you have 2 more minutes for the discussion.
So hello, everybody. My name is Harald Anlauf. I'm working at the German Weather Service and will be chairing the next session on So the next speaker is, well, probably you say your name yourself.
Oh, okay. Okay.
Ying-Jhen Chen.
Yeah, Ying-Jhen.
Oh.
Okay. I know it's a little bit hard to pronounce. Okay. Hi everybody. I'm Ying-Jhen Chen. I'm from Central Weather Administration of Taiwan, and today I'm going to present my topic is assimilation of GNSS radio occultation data in CWA's regional NWP system, and it's talking about our operational use and recent development. And first of all, I want to introduce our system named CWA Wolf. This system is based on Wolf model version 4.4.2 and Wolf data simulation system version 3.9.1. And we run the 2 domain. The parent domain is at 15 kilometer and the nested domain is at 3 kilometer. And our model have 52 vertical levels and model top is at 20 hectopascal. Our data simulation is using a hybrid 3D EMVAR, and we use the partial cycling with the analysis blending data simulation strategy. And we made our forecast 4 times per day, and every forecast then is about 5 days long. And the observation we assimilated in our system, including very kind of conventional data. And the only satellite data we use is Cosmic 2 radio occultation data reflectivity. And by the way, our global model named TGFS, and they use the Cosmic 2 data expanding angle. And next, I will show you our operational framework in our system. And we use the partial cycling, which means our initial condition is coming from the GFS, and doing the data simulation and do the analysis blending. Analysis blending means we blend our data simulation analysis and with global model. So after this operational framework, in our experience, this is how to evaluate the specific data impact in the regional model, since our model is lots of affected by the global model. So in our research, we trying to use the continuous cycling data simulation strategy, which means our system use continue to doing the data simulation, then just make a forecast directly without the analysis blending. And in this configuration, we can use get a sufficient time to accumulate and amplify the data impact. So by doing this, we are going to present our Cosmic 2 data evaluation in about the impact in our system. And since 5 years ago, the Cosmic 2 data, Cosmic 2 satellite has been launched, and we start to evaluate the data impact in our system. By assimilating the Cosmic 2 reflectivity data, we can see several improvements in our system. First, the Cosmic 2 reduce the forecast error as our synoptic scale. And second, they can make our system get a better initial typhoon structures, and which means it can reduce the typhoon track errors. And the following, I will talk about this detail in next couple slides. And by the way, this result is showing on our 15 kilometer resolution result. First, we take a look about our data QC result. We noticed that there are much data were cannot be left during the QC process. However, this this Cosmic 2 data still can make some effect, especially on the our system between medial to near surface. For example, from the mean analysis increment, you can see some positive increment showing on our system. So Cosmic 2 data do real make some effect to our system. And for the safety to our forecast result, we check the root mean square error. We can see the Cosmic 2 data can make the error reduction, not only in geopotential height, also in the temperature and the wind field and the humidity. And we also check the our impact in the typhoon analysis. And with our data, we can get a more realistic typhoon structure in this typhoon Hanshen cases, which makes the typhoon more similar to the satellite image. And we also collect almost 75 forecast cases to get realize this with Cosmic 2 data, typhoon track and intensity can make a good performance about our system. So now let's dive into the more technical issue about the observation operator. Until now, our reflectivity is operationally assimilated in our system via the local observation operator. And the local observation operator is assumed our retrieve reflectivity at the local point. However, this assumption cannot, without consider the effects of horizontal gradient. So we try to use another non-local observation operator to evaluate the data effect. And the non-local operator, which means it can integrate the reflectivity along the red path. So he can showing the regions with large horizontal moisture and temperature gradients. And this non-local operator has been implemented into the WRF-DA system version 4.0 and above, which calculate the GNSS phase on the mean altitude of a model layer. Okay, so let's make a simple table to compare the local and non-local operator. Then, as I said, the non-local operator consider the horizontal gradients, which means a non-local operator is sensitive to moisture and temperature variation. However, this makes it also the high computational demand. So non-local operator maybe cost a little bit expensive than local operator. But in previous study shows with the non-local operator, it can has increased probability of detecting detect the psychogenesis, and also he can shows the more accurate and earlier detection about the psychogenesis. And also with the non-local operator, he can make a better typhoon track forecast and also the better capture the TC dynamics. So with this advantage in this previous study, we want to try this non-local operator into our system. So we make experiment to test the local and non-local operator with our system. Here we use the WRF and WRF-DA on version 4.4.2. As I said, because we want to evaluate the data effect, we use the continuous cycling with Friday spin up, and our experiment period is from July 21st, 2023 to August 4th, 2023. And we totally collect 30 forecast cases, and every case has 72 hours forecast long. And the data we assimilated here is the same as the operational system we used. And first, we take a single observation test with a single reflectivity data and with different Cosmic 2 data type and operators. We can see the local run and non-local run analysis increment. In this two-dimensional distribution. And we make a cross section along the longitude and 135° east, we can see the increment here in the non-local shows the more symmetric than the non-local, and the non-local increment shows more elliptical, which is the typical shape because he considering the horizontal gradient effects. So it can show that this shape is very different than the local. And because here we non-local only use the gross error check, so we test make another test about use the local with relaxed QC criteria, which means we only use the gross error check. And also we can see the near surface has some increment characteristics showing up. So which means our observation system use more strike QC criteria, and in this in our next experiment, we use different type QC criteria between the local and non-local test. Here we take a look about our 15-kilometer domain average verification result. Between these two experiments, we can see the Roomy square, which means the forecast verified against the ECMWF 0.1 degree analysis field. The Roomy square cannot show the very significant differently, and we calculate the Roomy square error difference with the confidence interval. We found only the initial condition they are different, but other forecast ours is not are not, and the non-local one shows a little worse than local one. And also the similar characteristic can be seen in 3-kilometer domain, and also in the initial condition about the non-local run is worse than local one. And we also test about the typhoon track and intensity verification. And in this period, we have Dosuri and Kanu typhoon. And in these two typhoon, the non-local has a better forecast about the Kanu between their model track error and the intensity. The non-local shows better. However, Dosuri case is the local one runs the better. So the result of these two operator is mixed. And by the way, the Kanu is a very special typhoon track cases, which means the Kanu track has a dramatic turn during his when he crossing to Taiwan, and the non-local run test catch this dramatic turn earlier than local run. And last, we also test the precipitation verification, and in our we do the equitable threat score and the bias score. In ETS score, the non-local shows the ETS score is higher, means the result is better. So in non-local run, without both in light rain and heavy rain, the non-local has a higher ETS score than local run, and which means in 0 to 36 hours, the non-local run has a better precipitation performance. And for bias score, and the closer to 1 is better, and from the results shows the non-local one has a slightly higher bias score than local run, which means the non-local run is prone to over forecasting. So to summarize, our COSMIC 2 data radio occultation observation, now I mean the local reflectivity, have been operationally assimilated in our system since 2021. And in continuous cycling data strategy, the result shows our system has improved the tsunami forecast not only in potential high, also in temperature, wind, and moisture distribution. Also, it can make a better typhoon track and intensity forecast. And also in our recent study, the non-local reflectivity operator also be investigated with our system. And this is the first time the non-local operator for our assimilation is used testing with our system. And although the domain-wise root mean square error of analysis from the non-local run is slightly larger than the local run, the differences in forecast are not significant. And for typhoon track and intensity forecast, the results are mixed. However, we only show the two typhoon cases. We think maybe we need to take more cases to analyze. And for the precipitation forecast, the experiment with the non-local operator shows higher ETS score in the 0 to 66 hours forecast, especially for the intermediate to heavy precipitation. And during our experiment, we noticed the computational time is more than 6 times longer than the local operator, which means the higher computational demand of the non-local operator makes it difficult for operational use right now. And so in the future, besides running more cases, we think the quality control might play an important role. So next step, we will evaluate the forecast performance under different QC criteria. And that's all my presentation. Thank you, everyone.
Thank you for the nice presentation and staying well in time. We have time for questions. Ben.
Yeah, I think I have been asking this so many times, but I like your less future study because QC is so important, and your result actually is one of the best results I've ever seen. But your QC is actually cut off almost below 4 kilometers or something. So can you give me the reason, the physical reason that you actually do not using the data, but you are doing pretty well?
Oh, well, actually, I have tested a lot of method or criteria during our study about the cosmic data impact. But as in my experience, actually, I can get, I noticed they're not significant improve to our forecast performance. So, as I know, I don't even know, maybe there will be maybe some new technique or some issue to can support our results. We still need more tests.
So are you saying that your QC, after you testing so many things, and
Yes.
this QC actually performed the best?
By now, yes.
I know, but
Yeah.
you actually test several things, and this is the best QC you can have.
Yes.
Okay.
Yes, so I know the QC might be the critical role in this study. So if anyone has good idea, please tell me. Okay, and that's all.
Next question.
So you have local and non-local experiments, but they are using different observation resolutions. One is high resolution with using the ATM-PRF, and the other one using the NSAP prep buffer, right?
Yes, I know it's not the fair to compare these two because I just test these two different operator. Yeah.
Yeah, so I think that's not probably you cannot say which is better because the vertical resolution would play some role over there. And even, when you use different resolution observations, probably the QC ops error estimation could be different as well.
Yes. Yeah, we noticed that there's a lot of more detail to need to check later. Yeah. Thank you.
Another question? If that's not the case, let's thank the speaker again.
Okay. Thank you, everyone.